Example 23 on page 514. On rational exponents, to write a single radical expression for D2 radical expressions. So basically, we combine D2 radical expressions to one radical expression. Solution. So we're given D2 radical expressions. 3 cube root of 5 times square root. When you don't see anything here, it means square root or second root. Okay? Alright. First step we need to do is we will convert each to the exponent form. So I go from radical form to exponent form. So here, if you recall, the radical expression, we have a raised to some n power, and this is the n root. Okay, we can convert from radical expression to exponent expression by taking the a, and this m we'll treat as the numerator, and this n right here, the n root, we treat as the denominator. So we have a raised to m divided by n, and m divided by n is the exponent. So for this cube root of 5, I can convert this to 5 raised to, now you don't see the exponent here, it means 1, okay? So it's 1 divided by the root, which is 3, right? Divided by 3. Okay, using this formula, m divided by n. In this case, 1 divided by 3 time, again, you don't see this, it means 1. So you have time to 1 right here, which is 1 as the numerator, divided by, now this is square root. Okay, when you don't see it, it means square root. Okay, so there's a 2 here, which is second root. So that means we'll have 1 divided by 2, okay, which is the root of this square root. Now we have 2 exponent expressions. The goal is to combine these 2, okay? So to combine the 2 exponents, expression 5 1/3 times 2 1/2. This exponent of 5 and this exponent of 2 must have the same denominator. Okay? Now, exponent of 5 is 1 divided by 3, and the denominator is 3. And this exponent of 2 is 1 divided by 2, and 2 is the denominator. Okay? Now you see that 3 and 2 are different. So we need to convert 1 over 3 and 1 over 2, okay, exponents of D2 base 5 and 2. D2 exponents must have the same denominator. So to do that, we find the LCM of the denominators, okay? Now the LCM can be found from using the factor from each denominator with the greatest number of times that it occurs. So for 3 here, it's only happened 1 time. So you put 3, okay? 2 here, again, 2 is just happened 1 time, right? Because 2 raised to the first power. Now, 3 and 2 are factors of D2 denominator. So we use them all, okay? Now 3 only happened 1 time. So I just put 3 time this 2 only happened 1 time. So I use this 2. So LCM is equal to 6. Now the LCD is equal to the LCM, which is equal to 6. Okay? So now we know that the LCD is 6. Our goal is to convert this denominator 3 to LCD, which is 6. And we'll do the same thing for this denominator 2 right here, and convert this 2 to the LCD 6. Now, starting from 1/3, to get to 6, we need to multiply by 2. Because 3 times 2 is 6. if we do that, we change the original 1/3, right? Because now we have 1/6. 1 times what? Equal 1, which is 1, right? 3 times 2 is 6. So we change the left-hand side. So to compensate, we need to multiply by 2. Okay? Because 2 divided by 2 is 1. 1 times 1/3 is 1/3. Simplify this, we have 1 times 2 is 2. 3 times 2 is 6. So 2/6 is equivalent to 1/3. The only thing different is that we get what we want, which is the LCD 6. Alright, how about 1/2? So we want to have denominator 6, right? So 2 times what is 6? 3, right? So we have here 1/2. Now, time denominator 3, we have 6. If we do that, we change this 1/2 on the left-hand side. So to compensate, we also multiply 3 on top. 3 divided by 3 is 1. 1 times 1/2 is still 1/2, and it's equal to the original expression. So now simplify. 1 times 3 is 3. Divide by 2 times 3 is 6. Now we obtain the equivalent form of 1/2 is 3/6. And again, we got what we want, which is the denominator 6. And we want the denominator to be equal to the LCD. Do you see now that 1/3 is 2/6 with the LCD 6? Now what we want, how about 1/2? 1/2, now the equivalent form is 3/6, and we have the LCD as denominator 6. So that's good. Now I'm going to replace 2/6 in place of 1/3, and I'll do the same thing. I'll replace 3/6 in place of 1 divided by 2 here. So I have equal 5. 1/3 is right here. The equivalent form is 2/6. Okay, time 2. 1/2, the equivalent form is 3/6. Again, my goal is to get the exponents, the rational exponent, with the same denominator. We want the same denominator. Did you see that we go from 1/3, 1/2 to 2/6 and 3/6? And we have the same denominator now, 6, which is LCD. Alright. Once you have that, you can combine the two exponent expression using the laws of the exponent. So this here, 5, this 5 right here with the numerator 2 state time 2, this exponent 3 state the outside is 1 divided by 6. Okay? We're using the rule that A m n is equal to A m n, which is the law of the exponent. And you see, what we got is this, okay, which is on the right hand side. We can write the equivalent form by having the A to the m inside parentheses, factor out the n of the exponent outside the parentheses. Okay? Using the laws of exponent, we apply for each of these and then we combine them. Okay? Alright. And then you can check too. If you take 1/6 times the exponent, because this 1/6 is the exponent, so you multiply with the exponent. Okay? 2 times 1/6 is 2/6. And then 3, the exponent 3 times the exponent 1/6 is 3/6. Now, once we have this, we can use the formula that it say A raised to n power n roots is equal to A m divided by n. Okay, this is the radical formula we learned before. Alright, I'm going to apply this, which is given as the exponent expression. So we have this one right here. Okay, so treat the A as if it's 5 squared times 2 to the third. So the whole thing here, 5, base 5 and base 2 right here with its exponents is A. And this is m, which is 1. N is 6. okay? So we start from the right-hand side and we go to the left-hand side, okay? So right here, the left-hand side will have the root. So what does the n come from? N will come from the denominator, right, of this exponent, which is n. Now we have here the 6, so this becomes 6 root, and the a, which is here, go inside the radical. A here is the whole thing, 5 squared times 2 to the third power, okay, which is a here. Now we're not done yet. We still have to put the m right here, which come from the numerator of this exponent. And what is that? In our case, it's 1, right? So we have 1 here. Okay. And by the way, this is the formula, okay? I'm just want to reference so you know that how did I go from here to here? I'm using this formula. And to go from here to here, I'm using this formula, okay? Alright, I'm going to continue from here to here. So we have 6 root of 5 squared times 2 to the third raised to the first power, okay? From here, I go to here. So now, anything raised to the first power is itself, right? Think about 2 raised to the first power is 2. 10 raised to the first power is 10. So that means we can simplify the expression inside the radical as 5 squared times 2 to the third. Because anything raised to the first power is itself. Alright, we can continue with 6 root 5 squared. We can simplify this to 25 times 2 to the third power can be simplified as 8. Okay? Now 25 times a, so 8 times 5, 40, 0, carry 4. 8 times 2 is 16, 16 plus 4 is 20. So we have 20 here. Okay? So I'm going to replace the 25 times a with 200. Okay? Now as you see, we're done because we cannot simplify any further. So the answer, 6 root of 200 is the answer from this. Again, we combine given this expression with 2 radical expression, and we simplify it to 1 radical expression. And we combine by modify its exponents with the same denominator 6. Having that, we can use this formula to get this form, and then from here we can use this formula to write this from the exponent expression to radical expression, and then simplify, we get this answer.